A bacterial culture starts with 500 bacteria and doubles in size every half hour. First question is, how many bacteria are there after 3 hours? Well, 3 hours represents 6 doubling periods, because one doubling period is a half hour, which is 30 minutes. So if we want to know how many bacteria there are, well, that means that Y is going to equal the initial population, which is 500, and we're going to multiply that times 2 to the power of 6, which is equal to 32,000. Next question, part B, it says, how many bacteria are there after T hours? Well, in T hours, there will be 2 T doubling periods. The initial population is 500, so the population Y at time T is the following. It would be Y, which is equal to the initial population, which is 500, times the base of 2, raised to the doubling period of 2T. Okay, so part C, it says, how many bacteria are there after 40 minutes? Well, the first thing we need to do is we need to convert our minutes into how many hours that would be. So T is going to equal 40 minutes divided by 60, which reduces to 2/3. So now we know what T is, and now we can plug it into our formula from part B. So Y is going to equal 500 times 2 to the power of 2 times 2/3, which becomes 500 times 2 raised to the 4/3. So let's put that in our calculator. So we have 500 times 2 to the power of 4 divided by 3. And we get approximately 1259.9, which we can round that up to 1260. So that means the bacteria that's there after 40 minutes is 1,260. Okay, next question, part D. It says, graph the population function and estimate the time for the population to reach 100,000. So that means we're going to graph two functions. The first one is, we can call it y1, which was 500 times 2 to the power of 2t. We can graph the other, which is y2, which is equal to 100,000. So let's see what happens when we graph those two. So we have 500 times 2 to the power of 2. We'll call that x. And then we have y, which is equal to 100,000. Okay, so since we're going to 100,000, let's go ahead and put in, let's go from 0, let's say to 5. And then we'll go from 0 to 110,000. Okay, so there is our point of intersection. So we can see what our point of intersection is. So the value for x is at 3.822. And so answering our question, graph the function, estimate the time the population to reach 100,000. Well, we can say that the two curves, they intersect at when t is approximately 3.82. So the population reaches 100,000 in about 3.82 hours.